Hey y'all, it's Andrew Couch here. I missed last week's Tidy Tuesday, but I'm here today, and this week we are going to be analyzing beer production, which is pretty cool because for my capstone project, we actually are working with a beer distribution company, so I'm a little bit aware of the beer industry, but I am definitely not an expert. So we're just going to load in the data set already. We're going to load in the data set. I'm just going to do library Tidyverse, and then we're going to execute that. I'll call this Tidy Tuesday beer production. Okay. And for this project, I was actually looking at some other people's Tidy Tuesday work on this project, and I saw someone was using the GeoFacet package, where you could basically make a bunch of like mini charts and have it represent each like state. So I think that would be kind of a cool thing to do. I might just try it out, and we can do something pretty simple for it. So we see that there's actually a beer state. So let's first, I'm gonna delete this thing. So let's do a beer states. See what it's doing on-prem barrels. Okay. Let's do a ggplot x equals year, y equals barrels, color equals type, plus geom line plus facet wrap, state, scales equals free, and then end call. Let's say, I don't know. Let's do something even. So let's do 5 columns. Run that. It's gonna be too small, but we're gonna do some tweaking. Just okay. So theme. We actually probably want a position, but we'll say theme legend dot position. Legend dot position equals, is it top? And then fig dot width equals, we'll say 15. Fig dot height equals, I don't know, probably 20. And let's see what it looks like. Okay. So this isn't really that great of a plot. We could also add like kind of a, do I still have kind of like a cool little theme option to make it look a little bit prettier, right? Okay, so we have like, okay, an economist style. I need to change my scientific option. So scipen options equals 999, right? Oh wait, was it sci? Oh, it's options and then scipen 999. Okay. To be honest, this is actually a pretty cool chart. I'm gonna make this. Oh, why is it? Oh, there's more than 50. So what's? Oh, there's a total. And then what else is going on? What? Oh, and DC is included too. Kind of funny that they're saying DC is a state, but okay, so it does not equal total. So if there's 51 states, I guess we're gonna have a little guy over there. I'm actually gonna remove DC. So total DC, just to make it. Ooh. Oh, it's not n. So not n. So that way we just have a better, a better representation of it. Plus, it won't work with GeoFacets. I'm just gonna assume it doesn't work with it. So we're gonna do that, and let's just view it. Cool. So it's economist style. We can see just an overall trend. Okay. One thing that we could do is like a geom. And we're gonna keep that right there. Okay. So now I'm gonna look at the actual GeoFacet thing, the documentation. So we're gonna install it right here, and then we're gonna install. No. So we're gonna let that install, and then I'm just gonna put that in here, And while we're doing that, I'm going to read the actual documentation for it. So uses ggplot, okay. And I guess it's facet geo instead of facet wrap, okay. Seems pretty self-explanatory. I guess we have to do theme black white, maybe. Let's see what else there is. So we have to say facet geo state. Okay. Is that it? Does it just, maybe it just knows? Okay, so it kind of just knows the row columns of the grid system, I guess. So facet geo grid US state. I'm gonna use this one because this thing looks better. I think this looks more like America than this one. Right, this little like I didn't really know what this was at first. Kind of looks like Texas, to be honest. No, it doesn't. So yeah, we're gonna kind of look at that. So there's an EU thing, but you know we're American, and then they have a list of all of the grids. You know, maybe we'll just kind of experiment through the grids because you can see, oh wow, U.S. Iowa counties grid. Oh, that's. I wonder if they use my. I wonder if they use my grid that I created, U.S. Iowa counties grid. I would actually like to see that. I bet they did. I mean, I don't think they actually did, but we can hope that they did. Okay, so I'm gonna remove that. Okay, we're gonna put that in there. I'm not sure how it's gonna react with the theme, and let's just run it. And there we go. We have it, and we can see here that actually theme economist is not great, right? So let's do that. It kind of does take a long time. And then we have a cool chart where we gotta specify the scales. Let's see if the scales. Do I need facet geo? Interesting. So maybe we might have to add some kind of scale option. Scale X, facet geo. Uh-oh. Facet geo. Okay, facet grid label move axes true. I'm just gonna read this a little bit just so I can see if there's anything that I can actually put into. You know what? Maybe we'll do. I got an idea. We'll just do like a centering or something like that. Maybe I don't know. Because it's saying like, oh, some states are obviously purchasing more because they produce beer and stuff like that. So I want to see if there's any free scale. Scales. Okay, so there is. Okay, cool. So that means we can do scales equals free y or whatever. Scales equals free y. And we got it. Okay, cool. Maybe I wonder if it'll mess with it if I just say scales equals free. Maybe. Yeah, it kind of does mess with it, but you get an idea of it. I'm also gonna do what is it? Axis.text.x equals element.text angle equals, was it 90? Does that do anything? Yeah, okay. I don't really know if I like that. I think I might just remove the axis. So equals, I think it's actually element full blank. There we go. So no axis, and we just see the basic time series of it. Cool. I would clean up the the y-axis, but this is something where I honestly wasn't trying to look at it too much. I do want to make it a little bit smaller so you can see something nice with it. Free y. And there we go. We have some type of chart, barrels shipped. You can see you could see the trends overall, an increase, right? One thing that's kind of weird is like Colorado. I always thought that Colorado was a heavy beer production, which they are, but it seems like other states are kind of taken away from Colorado because their y-axis is huge for its scale. However, it's on a downward trend for Y, which is bottles and cans. So they're producing less bottles and cans. But we can see on the other states we're producing a lot, especially with like Tennessee and stuff like that. Cool. Okay, but that really wasn't anything that I wanted to actually deal with. It's a pretty fun chart. I would like to see the Iowa one. So how do I get grid names? I want to view that. How do I view a grid? Head US. Okay. So I'm going to look at this grid first because I actually have a Iowa grid, an Iowa county's grid. So I want to see Alamaki 1905 roll call. Just set. I'm going to see if I have it. School hex map Iowa. Because I actually created my own hex map for this. So let's see if that works with it. And I'm just going to Alamaki. Nope. Okay. So it isn't the same thing. Cool. Okay. So I didn't have to worry about anything crazy. Okay. But in this video, I actually wanted to focus on this other thing called profit, which is basically Facebook's forecasting model. And what I thought would be interesting is that we would actually forecast brewing materials. So looking at brewing materials, we actually get a lot of stuff. So first, we should probably do a basic EDA or something, or just like looking at all the factors and stuff like that. We have like I guess material type, and then like a material subtype. So it's like non-grain product, sugar hop type stuff like that. We got year, month, current, prior year, year to date, current, prior year, and we have a data type. I'm gonna count the data type. All right, 11440. Okay, so we don't really need data type. We don't need the data type because it's uniform. We're gonna count material type, and we're gonna count type too. So there's 12 rows. We have types. So we have grain type and non-grain type. And I think it'd be interesting to just forecast all of the types, right? So we definitely want type. Okay, and then I think since we have year, month, we should be forecasting purchasing. So like we'll forecast our months or like next month's current like what we should be using. Okay, so we're gonna do a select year, month, type, and then month current. I want to look at this just to make sure that we don't have to make any like leading variables or anything like that, lead or lag variables. So month current number of barrels this month. Do we have a usage? Number of brewers, range production, prior numbers, beer taxed, produce tax status, beer state, month current number of barrels. Okay. Barrel. And then let's see. Yeah, so let's just forecast like man, we could do just beer production make it a little bit easier, right? Where's state level beer production? How many? That's the materials. Where's brewer size, number of brewers, total brewers? Now we'll forecast monthly, I guess, malt and stuff with that usage. All right, so we have that. And so what's cool about Prophet is it's pretty high level interface. It really is simple to use. When I was looking at the documentation, it just takes in basically two variables, a data and like a y hat or a y prediction variable. So you just kind of give it year, month, day, date, and yeah, that's basically it. And then a y. So that's what we're gonna do. We're gonna actually just we're gonna say let's see here. First, since if we notice our month, right, doesn't have for year, month, day, dates, you actually have to have a leading 0 in the singular integers. So we're gonna just change that. So we'll say month equals if else month is less than 10, so we don't need to add a leading 0. We'll just say paste 0 month sep equals no separation, else we'll just do month as dot character right there. So we have it for each month, and we added a leading 0, and then we're gonna do mutate. We'll say year equals as dot character year. Oops, what the hell is going on here? Year, and then we'll say ds equals paste year month 01 sep equals that. So what we're doing right now is I'm saying like since we don't have a day, we're just gonna try to forecast, like we'll just say, oh, beginning of the month, we're gonna try to forecast for beginning of the month. This is something that's totally, I mean, I don't really know this data very well because it's like month current, right? So with production, it could be end of month or beginning of month. I don't really know how it goes for that, but that's what we're gonna do. And then we're gonna format this as dot date. Right, then we have a date. We have a year, month, date after converting all that stuff, and it was only with one mutate function. Okay, so now we're just gonna select ds type. We'll select actually type ds and month current, and we're gonna call this our model data. Cool. All right. So if we look at this, we'll say count type. We want to make basically a model for each production type. So how we're going to do this is it's a little bit odd because with like you could make a linear model, and this would be easy where you just do like nest minus type, right? And then you would kind of just like make a linear model. You do like a mapdf model equals lm what is it and then it'd be like, I don't know, month current and then it'd be ds data equals data, right? It'd be something like that. Oops. So map dbl lm bot. So it'd be something like that. But that's not really what we want to do. So we're gonna do this instead, because the Prophet object actually takes something else. So we're gonna have to do kind of like basically a partitioning of the data. So let's just start this. First, if we know that there's 10 different types, so we're gonna have to go through it 10 times and just like take out each type and make a model. So we're gonna do that. So we're going to do a for I in 1 through 10. And I'm actually going to do something so it makes it a little bit easier. So select type, and I'm going to use distinct. I used to use unique a lot. I guess unique isn't as efficient as distinct, so I'm just going to do that. Also, what I'm going to do is I'm going to actually add a name to it, so I can have like a shorthand for it. So I'll say malt, and I'll capitalize it. Why not? Malt, corn, rice, barley, wheat, total grain products, total grain, sugar, hops, hops is probably the most important. Hops, extract, and I'm gonna hops, and then dry, and then lastly we'll say other. What we want corn. Let's see here. Oh, I'm gonna have to pause this for a second. Hey, yo, I actually came back and was recording and finished up this actual Tidy Tuesday video. However, I actually found out that my mic was turned off. So I had to scrap, the half of the video, but I decided I'm gonna come back here and finish it up. So when I came back, I finished up the key that would allow me to basically have a simpler name, just for some modeling purposes. Additionally, I wanted to just kind of plot out the actual production stuff. So these are the I'm assuming product usage, or at least monthly inventory. So we can kind of see how there is some seasonal things. If you see how it's like kind of spirally, or it's kind of like a zig and zagging. So that's pretty interesting. There's some seasonal patterns going on. There's also a lot of like outliers, or like where there's a huge amount of usage. It might actually be a typo or like a scraping error, but I'm not really sure. So now we're actually gonna load up the Prophet package. And when I was looking at it, I decided that I'm just gonna do it kind of like the dirty way, where I'm gonna create a model results data frame, which will be empty, and that'll basically gather all of our model stuff. So in this chunk, I actually created a for loop from 1 to 12, and I did that because our key has 12 rows, so there's 12 different data sets. And I'm essentially subsetting the data through each specific key or type and creating a model from that. So I'm basically making these like micro level models. And within this for loop, I create a generic variable called model, where I take the model data, filter it using the given index of the key type. So since I'm going to do for I in 1 through 12, I'm just going to go through each item in descending order one by one. So it's just going to say, okay, we're going to filter out all products that are malt and malt products for the first iteration. And I'm going to just select DS and the month current, and I'm going to format it to Y because that's what Prophet needs, and I'm going to create the Prophet model. I also use this really handy function if you use a lot of for loops. It's called assign, and basically you copy that whatever object you want to copy, and then you give it a new name. So in this case, I'm just going to take the name. So I'm going to say like, oh, I'm going to make a malt model. So let's say malt model, and we have our malt Prophet model. And now I'm going to make and then I made a future, which I'm going to make a future data frame where I'm going to basically have it predict the next 3 periods, and I specify 3 periods. And these periods would then be, in this case, months. So in the next 3 months. And I chose 3 months because it kind of makes the most sense, because you don't really want to plan your purchasing for inventory like 6 months in ahead of time. It's probably easier to do 3, or even probably even 1 month, 1 or 2 months. So I thought 3 months was fine. I then apply the model. So I predicted the model with the future data. So what I'll do is basically fit the data to what we've already seen, and then also predict the next 3 periods. I select the date, y hat upper, and y hat lower, so we get some upper and lower bounds for our predictions. And then I just kind of add a type so we know our result and what's the corresponding y hats and values are for each model. Also format the date, and then I join the model data. And in this case, I'm going to join the model data because I want to compare the actual inventory with the predicted inventory internally. I then do a rbind where I'm going to just essentially append the data set to the model results. So I'm going to run that. It's going to take like, I don't know, about 20 or 30 seconds, which is pretty good because I'm training like 12 forecasting models over like, I don't know, like, you know, a few years. So then we get these some messages. It says we're not doing weekly seasonality or daily seasonality. That's because we only have monthly and yearly data, and we can also override it if we want to. So I'm gonna plot out the model results where I basically say the black line is the actual data, and then the red line, you can't really see it very well, but the red line or the colored line is what the model is predicting, and the range, the intervals are the y upper and y lowers. So you can see it's actually fitting it pretty well. I then decided that I want to actually compare my predictions with the actual and the predicted. So I do a just comparison plot, or honestly, it's kind of just comparing the residuals in a more interpretable manner for people who aren't really used to looking at residuals, where I fit the y-axis with the actual values and the x-axis with the predicted values, and then I throw in a random just a line that's fitted with a slope of 1. So ideally, we'd want all these points to be on the black line. But honestly, if we saw it all on the black line, that might kind of indicate there's some overfitting. However, so we kind of just want it to be around the line, because that means it perfectly predicted it. So if it's above the black line, it means it's over predicting. If it's under the line, it's under predicting. And we don't want it to be on an upper half or the lower half. We want it kind of be in the middle. You know, we don't have to be biased towards one end. Okay, so we can see here in hops, most of the data is centered around here. However, there's a bunch of like these outliers, and I think that's fine. I wouldn't want it to basically be predicting on these outliers. So we're looking at that. This isn't too good. You can see this huge gap where it's just like, it's kind of weird how there's like no interval in that was correctly predicted in this range. Again, here it's kind of fun because there seems to be huge variances in total usage. So I keep on going in. I create another plot too. I create another plot where I'm basically showing where the points are the actual monthly values, and the line is the fitted y hat. So you can see how it's really trying to capture all these seasonal patterns. See how it's kind of like spiky. And you can really see it fit really well with malt and malt products. See how it's really capturing these seasonal patterns. And then when it hits 0, it really like, you know, skyrockets down, and it's still trying to catch like a seasonality effect. Same with this one. The other, it really has this like kind of like crest shape that with some seasonal issues with seasonal stuff. Okay. And then finally, just like a generic, you know, I probably should have started with this where it's just showing the line, the y hat, and the actual, and seeing its interactions and seeing how it's trying to predict these actual trends. Cool. And then I did kind of a residual distribution plot where I kind of wanted to see like, oh, I wonder how much the distributions of it overestimating or underestimating. So blue is when the residuals or the difference is overestimating, and the red is when the difference is underestimating. Right, so we can see that. See the distributions. And you see right here, like it definitely, I don't know, I probably wouldn't make any crazy analysis, but you can see how it's really overestimating some of these total grain products. Same with sugar and syrups. Okay, and now to like the rule of fun stuff. So I was thinking about something where, oh, okay, I wanted to create like it'd be kind of cool to create like, oh, let's make like some micro forecasting models, right? We were already messing with the facet, was it GeoFacet plot with state beer production. But wouldn't it be cool if we could actually do like kind of a forecasted state beer production, right? So that's basically what I was doing right here first. So I said, okay, in this case, I did bottles and cans, but let's look at here. I think bottles and cans are the most used. So let's do bottles and cans. Bottles and cans are red, so makes sense. I think most people drink from bottles and cans anyways, especially with the coronavirus going on now. So I said, okay, we're gonna filter out bottles and cans. We're gonna select state, year, and barrels, and then we're just gonna mutate this where, since it's I believe like annual data, right? Since it's annual data, we're just gonna try to forecast the beginning of every year. Definitely not like a good idea. I probably wouldn't do that. Also, if I knew more about it, but if I knew more about it, I would probably have a better answer. But I just decided to do the first of the year. You could always do end of the year. Pretty much the same thing because they're the same distances away. Like New Year's Eve and January 1st are basically the same day. So I'm just gonna run this. Okay. So we have all of this. We're gonna group by state, and it was like, okay. So now we'll just kind of just use the model, like the profit function, as essentially just like a mutate function in a mutate. So we can't really use mutate. We got to use do, because when we're doing all these like funky little functions, we're gonna just have to do a better way to do it, a more like looser way to do it, where it's not gonna try to have any exceptions or anything like that. So I say, okay, we're gonna make a model object, and in that model object, we're just gonna give it our data. Since we know it's gonna group, it's to say, so for every state, we're just gonna give you this data. Cool. And then finally, we're gonna make a future data frame with our already made model, and we're gonna try to predict the next 2 years. And then we're gonna predict with our given model and our future data our results. And when I was looking at this, I realized that we could actually use the do function. I didn't think we could use the do function at the beginning when I made the original profit curve. So like for here, I could actually have done just a group by type and then a do model. So we don't really need the for loops. We'll say all the way of doing micro level models, right? So we can just use a do function, right? So basically we have a grouped data, right? We're gonna make a model with every grouped data. We're gonna make a future data set, which will be nested, and then we're gonna create a results data set. So we're gonna enter that in, and it's gonna take a while, right? Because we're trying to predict like 52 states for bottles and can production. Even though we don't really have a lot of data, it's only about like 5 or 6, I think 10 years, only 10 years or so. It will take a little while. Yeah, so we have like 10 years of data. No, we don't. We don't have 10 years of data. We have I don't know what we don't have that much data for it. So we're just gonna run this, let it go. So we're almost done. All right, dope. It also comes with this little handy progress tracking bar. So that's pretty nice. Those people at Facebook are pretty smart people. Okay, so what do we have here now? So we have 52 rows, and we have a nested model, a nested future data frame containing our data that we're trying to predict, or like our dates that we want to predict, and then we have our actual results. Okay, so we're just gonna unnest results. Okay, and we're gonna select state. We're gonna select state ds y hat y hat upper and y hat I think lower. Okay, so we have all the predictions for these states, and we're also gonna I guess yeah, and then we're just gonna ggplot it out. X equals ds, y equals y hat, color equals state plus geom line plus geom, and we'll say, I'm trying to think of how should I visualize it. I kind of do like the ribbon chart, so I kind of do like this ribbon chart right here. So we're gonna do that. So plus geom ribbon, and we'll say as y max equals y hat upper, y min equals y hat lower plus okay. And then, and also we're gonna do, I'm gonna do alpha, a really small alpha. So I'll say alpha equals like 0.1. So I'm just gonna run that first, just to see if I like the alpha for it. Oh, and I need the fill equals state. Okay, so I'm actually gonna change this. So I'm gonna make the color equal to black. Okay. Oh. Okay. Color equals black. Maybe I can make the. I'm gonna make the. We'll worry about this later. Okay. So facet geo by state, and we'll say grid equals US state grid 2, scales equals free. Okay, and then I'm gonna do theme legend dot position equals none. And I'm gonna do fig dot height equals 15, fig dot width equals 15. Okay. What's going on here? Oh, okay, so the years are a little off. So I got an idea. I'm gonna do a mutate too. Say mutate ds equals ds minus 2000. Okay. I'm not sure why it's doing that, so okay. Okay, well, so we have that, and I'm gonna do a plus g labs, and we'll say title equals forecasted what was it, like beer bottle and can oops, what is called production. Yeah, forecasted bottle and can production, and then we'll say subtitle using profit. Whoa. And I'll say micro level forecasting using profit. Cool. I'm not sure why it's getting cut off like that. That's kind of annoying. Let's see here. Oh well. I'm gonna choose gg save and say forecast.pdf plot equals last plot, and then width equals 32, height equals 18, units equals inches. We'll save that. And I'm gonna go, where is it? Tidy Tuesday forecast, and we'll view it. Oh, there we go. Forecasted beverage deals with profit, which is a little bit bigger, but you know what, it is what it is. So yeah, I hope you learned a little bit more about like forecasting and basically how to make micro level models. It's actually pretty simple. You just kind of have to switch out the mutate function with do. So yeah, hopefully I'll see you next week, and yeah, tidy on.